Now, first of all, the question given to us is f of x is equal to ay square, and the limits are given from 0 to y to x to 1, and it is 0 otherwise. Now, first of all, working out the limits of this density function, it is clear from here that y is between 0 to 1, and therefore the limits of y are from 0 to 1. And for x is smaller than mod x. There are two cases, that is x exists between -1 and -y, and x is between y and 1. We get the limit of x and limit of y. Now, first problem is to find the value of a. Now we know that for probability density function, the integration from -infinity to infinity is 1. That is, the area under the probability density function is 1. Now here we are given the limits, and therefore putting the limits, x is from -1 to y is from 0 to 1. Similarly, y is from 0 to 1 and x is equal to y to 1. Solving the entire integral, we get area is equal to 1. Equating the equation to 1, we get the value of a, which is equal to 6. This is the value of a, and therefore the density function which we get is 6y square. This is the entire calculation. Now, moving forward. We have the density function as 6y square and the limits. Now, limits of y is from 0 to 1 and x is from -1 to y and x is from y to 1. Finding f of x and f of y, that are the marginals. While finding f of x, we need to integrate it over y. That is, we want to find the function in terms of x, and therefore integrating it to the limit of y. Now here y is from 0 to x, that is, we want the function in terms of x, and therefore we take the limits from 0 to mod x, which is here y is from 0 to mod x, as we want the equation in terms of x, and therefore integrating it, we get the marginal density of x, that is f of x, as 2x cube, and that is mod. And here it is important to note that this function, this mod function, is an even function. It can be considered like a sort of this sort of function. That is, had it been x cube, it was the function would have been like this, but it is mod, and therefore this negative is converted to positive. That is, this sort of the function is mod x cube. In short, this is an even function. That is, it is symmetric about origin. And now f of y, that is the probability, the marginal density of y. To find the marginal density of y, we integrate it over x, that is finding the entire equation in terms of y. Putting the limits, as we know that x is from -1 to -y, x is from -1 to -y, and x, the other part of the x, is from y to 1. That is, we get y cube upon x plus y cube, y cube upon 3 plus y cube upon, that is integrating in this equation, and we get 4 1 minus y cube. This is similar, that is, this is also an even function, and even function become twice, so we get this f of y. That is, if we integrate an even function, that is adding both the sides, we get twice of that function. That is, f of y which we get is 4 1 minus y cube. Now finding the conditional densities, right? F of yx, that is f of xy, that is function of f of xy upon f of x. This is the general equation or the formula we can say. We know we have found the equation that is 6y square, which is the f of xy equation, and f of x we just found it, that is 2x cubed. This is the conditional density. F of y given x is given. Similarly, f of x given y, that is equal to f of xy upon f of y, and we get this equation. Now finding the first order moments, that is the means. We need to find the mean, that is a e of x, e of y, expected value of x, expected value of y, expected value of xy, expected value of y given x, and expected value of x given y. Expected value of x, that is integrating x f of x, that is f of x is the marginal function of x which we just found out, and x integrating it from -1 to y and y to 1, which are the limits of the function. Now here there's a slight you need to pay attention over the calculation, that is this particular function x is an odd function. We know that f of x is even function. We just saw over here that it is 2x, 2 more x the whole cube, therefore it is an even function. This is an even function, this is an odd function, therefore the entire function is an odd function. Now here the limits are from -1 to y. We change the limits, that is we integrate from x is equal to y to 1. While changing the limits, we also change the signs of the limits. That is, here we used to integrate from -1 to -y. Here we change the limits and we also change the sign of the limit, that is integrating it from x is equal to y to x is equal to 1. Besides this is an odd function, and therefore we have to put a minus sign over here. This indicates that the function is odd. Had it been an even function, we need not put a sign over here. Now this part plus this part is again 0, and it is evident that odd function, when it is when the mean is calculated, it is over a period that is symmetric about origin. Suppose we take any function and we say we have a function like a cos function or whatever. It is even on both the sides, and if we integrate it over a symmetric period, say -1, 0 to 1, the period is symmetric, and if we integrate over it, it is a 0. This is an even function. I was talking about a sine function. Sine function, say like this. Sine function, when we integrate it over sorry about this. This is an even function. We say sine function, suppose say sine x, and we integrate it over a symmetric period, a period that is symmetric over origin. We get 0 mean, right? So in short, the expected value of the odd function over a period that is symmetric from the origin is 0. Now e of y, integration from y is equal to 0 to 1, y f of x dy, and we get the expected value of y as 6/5. It is simple, just putting the limits of y, we get e of y. Now expected value of e of xy. E of xy is integrating with integrating the entire equation f of x, putting xy and the same limits as we used initially, and again integrating the equation, we get mean of y xy, that is equal to 0. Now here it is important to note that e of xy is equal to 0. Besides that, we got e of x is equal to 0, and therefore e of xy is equal to e of x into e of y, which indicates that this function is uncorrelated. This function is uncorrelated. This function is uncorrelated doesn't mean that it is necessarily independent. However, if it is independent, then it is uncorrelated. Here, in this case, f of x into f of y is not equal to f of xy in our case, which indicates that this function is not independent. However, this function is uncorrelated since e of xy is equal to e of x into e of y. Now, we need to find e of y given x and e of x given y. If y given x, we have this function f of y given x, y, integrating it over y, we get the equation as, the mean, conditional mean as 3 by 4 mod x. And similarly similarly finding the mean of x given y, we have the equation, we putting the limits of x from -1 to y and y to 1, and calculating the entire integral, we get mean of x given y as 0. Again, this is an odd function, and therefore again the same concept over here. There is changing the limits. X, we know that it is an odd function, and integrating the odd function over the period that is symmetric about origin, we get the mean as 0. The same concept of changing the limits, changing the sign of the limits, and since it is an odd function, we put a negative sign over here, which is as indicated. The mean is 0. So this was the entire analysis of the function, probability density function a y square, and looking this graphically, we can observe it like this, that we know that y goes from 0 to 1, and we know that x goes from -1 to x is equal to -y, and x is equal to y to 1. We can take any of the strips. Suppose if we take the vertical strip, then this vertical strip goes from -1 to 0, -1 to 0 if it is x, that is moving this strip to and fro in this direction. We get the limit of x is equal to -1 to 0. However, this limit, the lower end of this limit is y is equal to 0 to the upper end of this limit is y is equal to -x, which is this line, and therefore if we take the vertical strip, these are the limits. However, if we take the horizontal strip, moving that strip from 0 to 1, which is along the y-axis vertically, we get the limit of y is equal to 0 to 1, and we can say the left end of this strip is on x is equal to y, and the right end of the strip is x is equal to 1. Therefore, this strip is between x is equal to y to x is equal to 1, and therefore the limits of x is from y to 1. The integration can be carried either way out, depending upon what type of strip you take, either vertical or horizontal, and the limits may change depending upon that. So this is all about the function that is a y square. Thank you.